space friend, I figured out that this ship has a built-in artificial intelligence system called ChatGPT, which I'm guessing stands for Gamma Ray Party Time. That's very dangerous. I've clearly proven that I don't always make the best decisions in our repair work, so let's test out this AI by seeing what it thinks I should repair next and how it thinks I should repair it. With this, we're also going to get some practice with interpreting and correcting code.
Welcome, new user. I am this ship's artificial intelligence system, ChatGPT, short for Chat Gamma Ray Party Time.
Nailed it.
Please enter your query.
Write Arduino code for a beginner-level project that is set to the theme of repairing a broken spaceship.
Here is Arduino code that simulates a spaceship repair tool that includes an LED.
We're not starting off great since me being in a broken spaceship is real life and it wants me to just simulate a repair, but we'll see what happens.
Yes you will.
So when you have ChatGPT write you Arduino code, it gives you a helpful description of this is what the project is supposed to do, here's the code, and then it gives you steps for what each line of the code is doing. But the code isn't always perfect. It's good, it's very impressive, but it's not perfect. So we're going to put in the code as is, try to run it, see what it does, see if it even compiles, and then we'll fix what we need to fix. So I had to change a few things straight away, but that's probably due to just the type of LCD I have and not Gamma Ray Party Time's fault. Once we fix the LCD setup to match what our actual device is, then we just declare some variables. Then we're initializing an array of pointers to strings with some specific system names. Let's break down each part of this code. Car, asterisk, system name, system count. This declares an array of character pointers named system names. The size of the array is in the brackets and it is determined by the value of the variable system count. If we change the number assigned to system count above, then the size of the array will change as well. Car you know what I'm saying, indicates that each element in the array is a pointer to a string. This whole life support, power, navigation, and communication is initializing the elements of the system names array with a list of string literals and enclosing it in curly braces. Each string is in quotation marks and separated by a comma, so we've got 5 strings total. These strings are the names of various system names, and they're going to be stored as character arrays in memory, and then the addresses will be assigned to the corresponding elements of the system names array. Doing this creates an array of system names that we can access in the program using indices like system name 0 to retrieve the name whole, or system names 1 to retrieve the life support, and so on. This creates a Boolean array, so either true or false, of size system count, so 5. We're setting all 5 systems as false to start off, and also initializing selecting system 0, so the whole. The setup is setting pin modes for the LED and button, and then initializing the LCD. I'm going to have to change some things here though, because this isn't how you initialize my specific LCD. We're also printing Spaceship Repair for 2 seconds. The loop checks if the button is pressed. Since we set the button to input pull up, it's pulled high, and low means that it's pressed. Selected system now equals selected system plus 1 modulo system count. So it was 0, now it's 1. This percentage sign is a modulo operator, which calculates the remainder of the division of the left operand by the right operand. You can use this operator to restrict something to a specific number of possible values. So modulo system count is ensuring that the selection loops back to 0 whenever it reaches the maximum of system count. Display system status is then calling a function that we'll get down to below the loop. Next, we're simulating the repair process by saying if the status of the currently selected system is true, that system needs repair, and to move on to the code inside this if statement. Then it will use digital write to turn the repair LED on and delay by 2 seconds. Then it will turn that repair LED off, and the system status for that particular system will be false again. So our simulation is using an LED to be turned on while we're fixing something on the ship, and then it will turn back off when we've fixed it. Now the display system status function. First it clears the LCD and then sets the cursor to start in the upper left-hand corner of the screen. It prints repair and the name of the currently selected system. Then it moves the cursor to position 0, so the first position on the second row, and prints status, the selected system, and either repaired or needs repaired. This last line is using the ternary conditional operator, which evaluates the test condition and executes a block of code based on the result of the condition. It goes condition, question mark, value if true, colon, value if false. So in this scenario, if the selected system is true, that indicates the system is repaired and it will print repaired. If the status is false, that indicates it still needs repair and it will print needs repair. So here's my recap of what I think this project is doing. We're going to press a button to cycle through the 5 broken ship systems. Initially, they're all going to start off at false, which means they're still broken. If the button is pressed, we'll cycle to the next system. On the first loop, we'll print repair, the system name, and status needs repair. Because it's still set to false the first time, we call this display system status function. Then we simulate the repair process by turning on an LED for 2 seconds, which means we're fixing the system. Then once the LED turns off, the system is fixed and the status is false again. Wait, now I've confused myself. Does true or false mean that it's broken? I don't know how this code is determining that you fix something. If it starts off at false and ends at false, how does it become true? I feel like we're missing a step. Let's just hook it up and go from there. So it does say spaceship repair, but then it cycles through the systems without me pressing a button. Pressing the button makes it pause on whatever system is showing, but it doesn't do anything else, and then the LED also doesn't light up. So let's troubleshoot what's making that happen. I feel like we should add in a second button to simulate the repair work. So I think next we're going to change the simulate repair process section of the loop because I don't see anything in this code that makes the status true just as it's currently written. So I'm changing this if system status to if the repair button is pressed, then we turn on the LED to simulate the repair and change the status to repaired. Let's see if that works. It works now. I'm genuinely giddy that I figured that out. Now, all 5 of our systems are repaired until we restart this program. I wouldn't say using ChatGPT required less work though, and we haven't actually repaired anything in this ship.
Are you insulting my program?
No, it was perfect and I'm the one that messed it up. Well, this is a concerning development.